To understand the wireless LAN theories, first we have to understand the wired LAN theory. So this is about the Ethernet wireless. So IEEE standards are 802.3. So IEEE has the standard for local area network that is coming under project 802. Therefore, all standards are coming from 802. So this standard, the wired network standard is this. So we have the physical layer. It can be Ethernet, token ring, token bus, like that. Normally, now we are using the Ethernet for the wired network. Then the data link layer is divided into two parts. This is very important. Data link layer is divided into two parts. That is the MAC layer and the LLC layer. MAC layer and the LLC layer. The LLC layer, what we do is the LLC layer may looking after the flow control, error control. So if you ask a question, what is the LLC functions of the LLC is that is the mainly for the flow control and the flow error control. So data link control handles framing, flow control and error control. So this LLC layer handles the frame, this flow control and the error control part. So this part we can skip, you don't know to study that. Then the MAC layer, media access control layer, what are the things it can do is the access to the media. So access to the media should be done without any collision. Then what is the media access protocol we can use? CSMA-CD, CSMA-CA like that. In the wired local area networks, we are using the CSMA-CD as the media access control protocol. So Ethernet, we have different flavors. Standard Ethernet 10 megabit per second, fast Ethernet 100 megabit per second, gigabit Ethernet 1 gigabit per second, and then even the 10 gigabit per second Ethernets are there. These are all fiber. So MAC layer, so this is the frame of the MAC layer, is the Ethernet frame. Now look at the frame fields here. So obviously you need the source address and the destination address. We know MAC address has 48 bits, that means the 6 bytes. So we have the source address and the destination address. And this preamble SFT in the start frame delimiter, these are for synchronization of the frame. The frame is going at the receiver, it should be synchronized with the frame. And the length of the frame and data and padding is there is a minimum length in the frame. If the amount of data is less, it is put in some dummy bits called the padding here. Then you have the error checking. Normally, every frames have the error checking part. So here the error checking part is the CRC, cyclic redundancy check. So this is the frame of the Ethernet. So then I will go to the wireless. The wireless is in the chapter 13. So this is wireless. This multiple lectures. We have discussed about this one. So I go to the this is wireless LAN. The wireless LAN, The standard is 802.11. Standard is 802.11. Okay. So in the architecture, we have something called the basic service set. The basic service set, we have two types. One is the ad hoc network, and the other is the going through a infrastructure network, or it is going through access point. Now in the ad hoc wireless networks, you can directly coordinate from one station to other station. And the other method, it should go through a central place. Now here it is called normally access point. It is access point. Then there is another type called the extended service set. It is just like you have say several floors of a building. You have one access point. This is one floor. This is another access point. This is another floor. This is another access point. So this is another floor. Now they are connected putting a wired net, some kind of cable. So there is a server or the gateway to control this one also. So this is called the extended service set. In the extended service set, I'll explain what is the extended service set, how it is working. Now here, this is data link layer. We remember in the wired network, it was divided into two parts called the LLC and the MAC layer. Again, in the wireless networks, MAC layer is divided to two parts. MAC layer is divided to two parts. We don't want to go in detail these things. Just remember, it can be divided to two parts. In the physical layer, it can be FHSS, DSS, and the OFDM. So with these things we discussed, so that can be there. Actually, it should be OFDM A. So then you have to understand the frame structure. The frame structure, this is the frame structure of the wireless networks. So you have this frame format: FC, D, address 1, address 2, address 3, SC, address 4, frame body, and FCS. Again, you can see the FCS, frame check sequence, means for the error checking part. Now here, this FC is the field we are adding to control this wireless network, so called the frame control. It has 2 bytes long and define the type of frame and some control information. So what are the things they are? Its version and type of information. There are 3 types. It's the management, control, or data. So management and control is for the establishment of the connection. Initially, we are using these 2 frames. Then the subtype 2DS from DS, then wireless equivalent privacy encryption method. This is the wireless security part. Now, see the next field D. D in all frame type except one, this field defines the duration of the transmission. How long it will be duration, the transmitted. Then you have to be, you have to understand about these things. Address. There are 4 address types, and each address 6 bytes long because it's a MAC address. The meaning of each address will be depend on 2DS and from DS. I will explain that part. Then there is a sequence number for frame, that is sequence control. Then the frame body, this is the data part. Then the frame check sequence is the error control part. It's a CRC32 error detection sequence. Now I told you there are 2 types of control frames. So one is you can make the connection. Control frames are used for accessing the channel and acknowledging the frames. So Earlier theory explained about these things, RTS, CTS, I didn't explain that one. But the request to send, before you make access to the network, you send a frame called request to send. Then if the media is clear, you get the clear to send, CTS. So these things, in the 1011, in the subtype, you have 1011 is the request to send, 110 is clear to send, and 1101 is acknowledgement. So there are 4 bytes to explain that one. Then you have addressing mechanism. There are 4 addresses. How these 4 addresses are coming is explaining here. In the ad hoc network, it is going from one computer to other computer. Directly it is going. So this is the scenario 1, that is 00 to DS0 from DS0. Then the address 1 is destination, address 2 is source. Address 1 is destination, address 2 is source. So here, address 1 is the computer B's MAC address, address 2 is computer A's MAC address. Then 01 means now this base station ID is there. The basic service set ID for that particular network ID is there. Then 01 is it is going to an access point. 01 is it is going to access point. Access point, so that is there. Then what are these addresses? Address 1 is destination, address 2 is sending AP, address 3 is source. So it is using 3 addresses. The 4th one is not using. Address 1 is for always the destination. It is here destination. Address 1. Address 1 is destination. Address 2 is sending AP. That is the access point number. And address 3 is the source IP. It is coming from somewhere. So it's the IP address. That is it can be the computer A if it is sending by it. Right? So if the A is going through access point, then it is going as 01. Then the destination address is 1. Address 2 is sending AP. Then source IP. Next one is this scenario. It is going from this computer A to access point. Computer A to access point. That is 10. Then the address 1 is receiving AP. That is this one. Address 2 is source. Source is the computer A. And address 3 is the destination. So destination is the computer B. Right? And the third scenario is it is going through 2 APs. So these are 2 BSSs, the extended network. So here you can see from A to AP1 it is going. A to AP1 part is this one for scenario. Then the AP1 to AP new thing is there. So there are 2 access points. The frame is the frame is going from the AP1 to AP2, it is the 1-1 scenario. Destination 1 is receiving AP. Address 2 is sending AP. Address 3 is destination. Address 4 is source. So these are the 4 cases we have in the wireless network. So wireless network, you can have one computer to other computer directly. In that case, this is the 00 is the scenario. Other scenario is it can go through access point. When it is going through access point, you can see A to access point, then the access point to B. So there are 2 steps. So when it is going A to access point, that is 10 scenario. And access point to the B, it is 0, 1 scenario. Then fourth one is the computer A belongs to one access point, computer B belongs to another access point. So it is going the A to AP1, and the AP1 to AP2, AP2 to B. Now, can you tell me this fourth scenario? When the source is going from A to AP1, when the frame is going from A to AP1, what is the scenario for that frame? A to AP1. Can tell somebody? Out of these four scenarios, when the frame is going A to AP1, what is the scenario? That part. A to AP1 is this scenario, that is case 3. In the frame, the same network, same one. When the frame is going from A to AP1, it is considered as the case 3. When it is going from AP1 to AP2, it is considered as the case 4. AP2 to AP2 to B, what is the case considered? AP2 to B. Can tell somebody?
Case 2.
Case 2, yes.
Case
Case 2, yeah. So that is that frame in this case 4 scenarios, frame is going in 4 steps. Step 1 is the case 3. Step 2 is the case 4 itself. Step 3 is the case 2, right? So by reading this one, you can understand that. Then you have this hidden station problem that I am not going to explain since we have limited time. Then physical layer 802.11, the techniques we are using the F11 is the first one actually, FHSS, DSSS, and this is the frequency band it is using, and this is the modulation it is using. It is the bit rate is 1 megabit per second. It's a very old system, very first system. Then we have the different versions came 802.11a, 11b, 11g, like that. For wireless communication, there are 3 main bands are there. That is, these bands are from 902 to 928 megahertz. There are 26 channels, 26 megahertz bandwidth, and widely used frequency band is the 2.4 gigahertz to 2.4835 gigahertz. It has 83.5 megahertz band. Third one is the 5.725 to 5.850, that is 125 megahertz. Right? So this 2.4 to 2.4835, normally we say 2.4 gigahertz. And 5.725 to 5.850, normally we say 5 gigahertz band. Right? So if I ask a question that how many frequency bands are there to use wireless communication, actually these are called the unlicensed bands. You don't want to get the license to operate in these frequencies. Because other frequencies, if you want to operate, you have to get the license from the Telecom Regulatory Commission. So this band is called the Industrial, Scientific and Medical Band, ISM band, Industrial, Scientific and Medical Band. So this has 3 bands are given. Widely used band is the 2.4 gigahertz band. Now, since the 2.4 gigahertz band is not sufficient for, because almost all devices are wireless now, so many channels you need, therefore we have moved into the 5 gigahertz also, right? Okay. Then I'll go to another one in the LMS. wireless network. Wireless LAN. Different standards. What are the different standards of the wireless LAN? Right. It started with the 802.11. So it is the frequency open spectrum sequence or DSS, both they use. So if the bit rate is, you can see it's very low, 1 megabit or 2 megabit per second. So then the 802.11a, so that is 54 megabit per second in the 5 gigahertz range. So 11a, you can go to you can use the 5 gigahertz range. You can see it jump from 2 megabit per second to 54 megabit per second. Then the 802.11b, it's 2.4 gigahertz band. Then the 11e, so the different features are there. Then the 11g, 11, you can see 11n, it is in the MIMO antennas. It's used the MIMO antenna. This can go to about 250 megabit per second speed. Then 11AC, it is in the 5 gigahertz band. It can go to 1.3 gigabit per second speed also. Right? Likewise, the different standards are there. So nowadays we are using the 11AC for the 5 gigahertz band and 11N for 2.4 gigahertz band. These are very high bit rates. Right? Any question from this? So then I'll go to the wireless channels, Wi-Fi channel frequencies. So this frequency band, different channels are there. So I will explain about those channels. Then you can see Wi-Fi channel. There's a it's a Wi-Fi channel. We have to see only 3 frequency bands. I mentioned 900 megahertz, 2.4 gigahertz, and the 5 gigahertz. There are other frequency bands also used by the different countries. Now 802.11, 2.4 gigahertz, 5 gigahertz, different frequency bands can be used. In the 2.4 gigahertz, these are divided to 14 channels. You can see channel 1 is 2401 to 2412. Channel 2 is 2406 to 2417. Now there is an overlapping area. You can see channel 1 is 2401 to 2412. Its overlapping area is there. The channel 2 is 2406 to 2417. Again, overlapping area is there. Then to channel 3 starting with 2411. But channel 2 ending at 2417. Then you can see overlapping area is there. Now, although there are 14 channels, if you carefully see, there are only 3 non-overlapping channels are there. There are only 3 non-overlapping channels are there. So this is there. This is channel 1, channel 2, channel 3, 4, 5, then the 6. You can see 1 and 6 are not overlapping. When you see very carefully, only 3 non-overlapping channels are there in the 2.4 gigahertz. Then Then the different regions, Europe, North Africa, Japan, they have some are available, some are not available, some channels they are not using this here. Then 3.6 gigahertz we can skip. I will go to the 5 gigahertz band. The 5 gigahertz band, you have many channels like this. So they are given the channel numbers 36, 40, 44 like that. So this one has, each channel has a higher bandwidth than the 2.4 gigahertz. And very high bandwidth also you can use. I will explain that one. There is a video for this one. Now I will share that video with you. That is Wi-Fi channels.
Welcome to part 2 of our Wi-Fi Air Expert video series. In this video, we'll cover the frequency bands and channel numbering used by Wi-Fi equipment. The 802.11b, G, and N standards are designed to transmit data over the 2.4 GHz frequency band and use frequencies from 2.4 to 2.5 GHz. The 2.4 GHz frequency band, also called the Industrial, Scientific, and Medical, or ISM band, has been released by the FCC for unlicensed use. This means a lot of different types of equipment can use it without requiring a license. In addition to Wi-Fi, other devices like Bluetooth, Zigbee, cordless phones, and even microwave ovens use the same frequency band. The 2.4 GHz band is divided into 14 channels spaced 5 MHz apart, beginning with channel 1 centered on 2.412 GHz.
So the space between two channels is 5 gigahertz.
Since it's easier to remember channel numbers than center frequencies, people use channel numbers from 1 to 14 to describe which channel their device is using. 802.11 RF modulation techniques require about 20 MHz in channel width to operate, but since, unfortunately, the channels are spaced 5 MHz apart, there is significant overlap and interference between adjacent channels. This is why, in the US, it's recommended that equipment be deployed on channels 1, 6, or 11, which are the only non-overlapping channels.
So you can see these are the non-overlapping channels. Okay? Not only these three, you can select some other combinations also without overlapping.
To make matters worse, the 802.11n standard allows the creation of 40 MHz channels by bonding two 20 MHz channels together in order to achieve a higher data rate. But this ends up creating even fewer non-overlapping channels and even more interference. In the US, the allocation is regulated by the FCC, and each country has its own regulatory agency. Channels 12 and 13, centered around 2.467 and 2.472 GHz respectively, are not allowed in the US but are allowed in the rest of the world, while channel 14, centered around 2.484 GHz, is allowed only in Japan. Channels 1, 6, and 11 are the only non-overlapping channels. The 5 GHz UNII, or Unlicensed National Information Infrastructure band, is less crowded than the 2.4 GHz frequency band and is used by the 802.11a, N, and AC standards. Center channel frequencies range from 5.180 GHz to 5.825 GHz. While the channels are 20 MHz wide, there is no overlap between adjacent channels. And once again, since
you can see in the 5 GHz band, you can have this small batch, 20 megahertz channels. 20 megahertz channel. How many channels we can have? 1, 2, 3, 4. Then 1, 2, 3. There are about 20 channels we can use here. Right? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. About 25 channels can be used, whereas 2.4 gigahertz, we can use only 3 non-overlapping channels. But these things you have the options to combine these two channels together and use for the 40 megahertz band also. And also you have the option to combine these in 4 channels and make 80 megahertz bands. And 4 channels and the more 8 channels, and you can make it 160 megahertz channels only. But these facilities are there in the 802.11 AC only. This the combination go to 80 megahertz and 160 megahertz channels.
It's very hard to remember channel frequencies. We use channel numbers instead. The first channel is 36, ranging from 5.170 to 5.190 gigahertz, centered at 5.180. The 5 gigahertz band is further divided into UNII 1, 2, 2 extended, and 3 bands. While most Wi-Fi devices will support only UNII 1, channels 36 to 48, and UNII 3, channels 149 to 165 for indoor use, the FCC and other regulatory bodies allow the use of the UNII 2 and 2E bands, provided that your device's radio can support dynamic frequency selection, or DFS, and transmitter power control, or TPC. DFS and TPC are designed to detect and automatically adjust Wi-Fi channels if military or weather radar systems are present in order to avoid interfering with these systems. If the DFS channels are used, the 5 GHz band offers a whopping 25 non-overlapping 20 MHz channels. Now, because the 5 GHz band offered what seemed like a limitless number of channels, the 802.11n and 802.11ac standards made use of it by bonding adjacent channels to transmit even more data. With 40 MHz of channel width, 802.11n and AC can roughly double their transmission speed, but at the cost of allowing only 4 non-overlapping 40 MHz channels, or 12 channels with DFS enabled. By bonding 2 adjacent 40 MHz channels into a single 80 MHz channel, the 802.11ac standard reaches speeds up to 1.3 gigabits per second, but at the cost of allowing only 2 non-overlapping channels, or 6 with DFS enabled. The 802.11ac Wave 2 standard defines a 160 MHz channel width.
Okay, I will share this video with you, then you can go through it. That is about the Wi-Fi channels. Any question from this?